Hey, good morning everybody, afternoon, evening, wherever you are. How are we doing? Bit of an earlier slot today, so apologies for that, but some that's going to benefit, especially our friends down under in Australia and in the Southern Hemisphere who will be able to actually join us maybe today. So welcome. It's always a bit of a compromise as to when's the best time to come on. Normally I do 2 o'clock, but we've got a street party in the village this afternoon from 2 o'clock onwards. So I thought rather than not know when it was going to finish and maybe come on at sort of 7, 8 o'clock this evening, maybe a bit worse for wear, I thought I'd do an earlier one instead. So that's the plan anyway. That is the plan. So again, there's no sort of deadline to finish dead on 2 or anything like that. I'm sure the street party will be in full swing by the time I get there. So the idea was to come on a bit earlier, and hopefully you caught Chris, All the Gear, No Idea, his premiere this morning. Very good on a UV exposure unit. I thought it was an EEPROM eraser, but it wasn't. It's an interesting bit of kit. So we've got a few people in already. I think we had Simon from Simon's World in first, who asked, what's the difference? Why does the RP18 sound better than the RP25? Now, it's got to be down to the amplifier design, because the sort of component count on the RP18 and the RP30, RP31SW, they all use the same amplifier. There's a lot more capacitors in it. So I'm assuming it's got a better tone. I'm not into amplifier design, so I can't answer the question 100%. But it's different impedance as well. So who knows? But as far as I'm concerned, the RP18 amp does sound better than the RP25. So we've got Timothy Can in. Hello, Timothy. Andy Beck. Now, this amplifier we're working on today is actually Andy Beck's amplifier. So glad you could join us, Andy, to see how I kill the amplifier. We also need to have a discussion, Andy, on what capacitors you want in this thing. So what's Timothy Can saying? Out of spec caps may be leaky, acting like resistors, messing up biasing. Michael Hyde. Hello, Michael. And Silverflyer's in. Wenlock's in. Good evening to you, Wenlock. As I say, good that you can join us today. Afternoon, Les, or morning. No, afternoon now, isn't it? Les. Harp's in. Harp prepping for a shooting competition. So good luck with that, Harp. And as I say, if you can get us a video, I'd like to see that. Ben Humphries is in. Hello, Ben. How are you and the missus? Sandra, I think, isn't it? Is it Sandra? And Rob Cross in with a super chat. Thank you, Rob. There's a new thing on the videos now called super support. So if you do miss the chance to do a super chat and you go back on some of the older videos, underneath on the row of icons now, there's a thing called super support. So if the video's helped you out and you want to say thank you, you can hit the super support now. And I don't know exactly how it works, but I believe it's like super chat, but for pre-recorded videos, or like live stream videos that are released after they've gone live. So that's got that rubbish out of the way. Thomas had to get up early today. Yeah, unfortunately it swings and roundabouts, isn't it? If I go on early, all the guys in the US it's earlier for them, but it is also earlier for the guys in Australia. I'm talking rubbish again. Chris is in. All the Gear, No Idea. Hi, Chris. Just had time to have a brew. I've only just had time to go down and get some beer. And hen. I haven't got any Erzquell. Erzquell. I haven't got any Erzquell. Oh dear. Andrew Mode. Afternoon to you, Andrew. Good to see you. Cyberflower. Hi, Cyber. Yes, apparently, Chris, they're putting up a load of shelters, and they wanted assistance at 10 o'clock today, but unfortunately with setting up the live stream, etc., I haven't been able to get down to give them a hand. But as far as I know, They're putting up some sort of shelter, but we're all going to have brollies. I mean, it'll be what it'll be. It's got to happen, isn't it? It's going to happen. And the more beer you get in you, the less you worry about it, really. Phil Taylor, how you doing, Phil? Rob Titheridge, afternoon, Rob. You would like to borrow some amps and put them on your audio analyzer? Oh, yeah, that would be great, Chris. Actually, I've got a box full here, mate, so I can send you up a selection of the different Hacker amps. They would be in varying states of repair, though, so you might have to tweak some of them. We'll sort something out, Chris. Send me a message on it. Afternoon, Benji. Sandra asks how I am. I'm fine, thank you, Sandra. Still was a bit ropey last week. It's been a very slow sort of recovery ladder, but I'm nearly there. Got doctors again tomorrow, so hopefully they can get to the bottom of what's up with me, literally. Brett, how are you doing, Brett? Stay tuned for midpoint and quiescent adjustments. Hopefully we'll get there. I'm sure we will. And Rob Cross has very kindly decided to buy me a weather station, people. So it's not something I asked for, but I've always fancied one. Rob knew that, and he's going to get me a weather station. So hopefully I'm going to be doing a little video series on putting all that together and putting it up. Putting up all the external sensors and that, so that will need to be a normal video, a pre-recorded one. Not that I do a lot. I must do some more pre-record videos. England need 2 runs, according to Andy B. Thank you, Andy. Cheers, mate. England need 2 runs. Fed the fox last night. We've had a lot of problems here with foxes, and Chris, all the gear, no idea, will know all about this. But we lost a chicken to a fox a couple weeks ago, and I was down the village hall on Thursday night, and a lot of people have lost chickens, ducks. We had one that the fox has got in and killed the lot of the chickens. We had another one where it's killed their ducks. I mean, it's rife here. I mean, they are a real pest near sort of farmyard animals. They can be a real pain in the backside. So they're not the most popular creature around here, Benji. Afternoon, Colin. Should stay dry this afternoon. Yeah, it's dry here at the moment. It's not raining at the moment, so you never know. England just won the test. Very good, Timothy. I haven't followed cricket since the days of Botham and all that lot. Unstoppables, good afternoon to you as well. Welcome. You listened to the test match on your old Cosa Melody Maker on Longwave. Ah, great stuff, Timothy. I think we need to use Longwave for as long as we can, and it's a real shame, but they are talking about closing it down yet again, aren't they? Which there was a petition back when they originally talked about it that was presented to Parliament, but I think the petition had 38 signatures, so you know that was a bit of a waste of time. Just 38 people in the whole of the UK decided that Radio 4 should stay on Longwave, which is pretty poor, to be honest. Maybe if they want to raise another petition, then we'll promote it on here. I'm sure you other chaps with YouTube channels would do the same. Right, so yes, today's video. I had lots of things planned, and then all of a sudden yesterday through the letterbox, well, not through the letterbox, but knock on the door from the post lady, and this amplifier has arrived from Andy Beck. Now, Andy contacted me a while ago and said that he bought this RP37A and plugged it in. Lo and behold, it didn't work. It was suggested that he try an amplifier from another set in it. He plugged that in, and away the amplifier went, away the set went. It's got other things wrong with it, but Andy's dealing with those. He asked me if I could actually have a look at if I could actually have a look at the amplifier for him. So I said, of course. You know, Andy's one of my long-time channel supporters and also one of my Patreon supporters. So never can do too much. Never can do too much for those people that support the channel. Hi from Susie. Hi, Susie. And the fur babies. So Chris is saying you just bought an off-air frequency standard that uses the 198 kilohertz signal. Yeah, I know. Hi Patrick. Yeah, I'm getting there, mate. Thanks for asking. What's Leslie saying? The old 1500 meters get us all over the UK. Good service. It is a great service, and I mean, it's apart from RTE and the French station, it's the only thing we've got on long wave now, and it is a national service. There was also talk about it being used by submarines, just to make sure that there hadn't been a sort of national disaster and the UK had been wiped out. Apparently, it's a bit of what's a bit of folklore maybe, but you know, they did say that someone somewhere said that the submarines did listen out for Radio 4. If they couldn't hear it, then they would take measures, etc. So there you are. So Richard's saying Radio 4 doesn't need to remain on long wave. There was a story that if our nuclear subs... Oh, there you go. Richard. It could be a bit of myth. I don't know. But when you say it doesn't need to remain on long wave, Richard, it's one of those things. You know, anyone can get Radio 4 on FM. I don't know if you can get Radio 4 on medium wave anymore, but the whole idea is long wave has got much better propagation. The signal travels a lot further. You know, a long wave Radio 4 can be heard outside of the UK. In fact, I can remember Manuel down in the Madeira Islands saying that he was able to receive Radio 4 in Madeira. So, you know, he's not going to receive Radio 4 on FM down in Madeira, is he? But on long wave he can. So this is the whole point of it. Oh, wrong way around. You were inferring they did. Just sent some images of his RP37A. We'll have a look at those in a minute. Yeah, I think the idea of petitioning the government was good, but for 38 signatures, you're never going to get nothing done with that, are you, really? Ridiculous. But there you go. If people want it, they've got to fight to keep it, because otherwise they'll just walk all over you, won't they? So I'm not sure what way to go with that yet. Could look at putting a petition up and then posting it in the Vintage Radio forum, seeing if there's enough support for it, maybe. That might be an idea. If anybody wants to do that. Anyway, let's have a look at this this amplifier. I've just pushed the wrong button now. Let's have a look at this amplifier then. So now this is my RP37A that I restored recently. Well, I haven't finished the restoration, but we certainly restored it electronically. And this is the amplifier out of it. Now this is the A205 amplifier. That's fitted to a few radios, not just this one. The Hacker Sovereign 2 uses this amplifier. I think the RP35 uses this amplifier. So there's a few different radios that use, well, different Hacker radios that use this same amplifier. And it is very good. They do sound awesome. And someone mentioned about the amplifier fitted to the RP18 earlier. Now that's this one here. And, you know, you can see the difference in capacitor counts. So, you know, it's a bigger board. There's a lot more capacitors shoehorned onto it. So this one would have been more expensive to manufacture than this one. And in my opinion, this sounds better. But maybe Chris can do some experimenting with these. I believe Mark Hennessy has done it as well, Chris, in the Vintage Radio forum. I don't know if he did the RP18 and RP25. I'm not sure. He probably did, because he did a lot of radios. He did the Roberts R707, R600, all that sort of stuff. But yeah, you can see the component count is a lot higher on the RP18, RP30 amplifier. That one, I think there may be issues with that, because I've got the output transistors disconnected from the heat shield, so that one's not working at the moment. I have got one somewhere that is recapped, so I could do that one and send it to Chris. But it would be interesting to see. So, but anyway, this is the amplifier in question. This is Andy's amp, and as you can see, it's still got all the old capacitors on it, but it is identical to this one. I could just swap them, couldn't I, and send this one to Andy? But let's keep it original. I don't know if there is any serial numbers on these. I don't think there is, so you wouldn't really know. You wouldn't really know the difference. No difference in behind. So, Racing Demon, how you doing? He had a power cut. Richard Milliken, you did receive Radio 4 in St. Augusta, Florida, from 6th floor condominium with a dangled wire on an old Russian multiband portable. Yeah. Jaden, afternoon Jaden. So Mike is saying, no mucking about, change T4 and check the output pair. Thomas, what are you saying? The US had Project ELF VLF for submarine communication. Interesting. Good to see you, Mike, anyway. I've not seen you for ages in the stream, so thank you for joining us. So that's the idea for today. Let me just start getting a bit closer. We'll have a closer look at these two amps. So I don't know what my supply of these blue Vichets is like. So Andy, do you want this done with Vichets? These blue ones, if I've got enough of them, or do you just want it done as cheaply as possible with radios? Good quality ones, mind you, not rubbish radios. It would be all 105-degree rated. I mean, in theory, they would be better than the blue Vichets, to be honest, because they've got a higher lifetime. But you know, the only thing with the Vichets is they do look the part, don't they? They do look a bit nicer. They do look a bit nicer. And as I say, that's the two amps. This is the one for today, and this is the one I did previously. So let's just connect up to this radio a minute then. Let me get my power supply sorted out. Let's zoom you back out a little bit. So I'm going to connect them up to this radio. First of all, we'll connect the one that I refurbed. Again, this has had everything done to it. It's had all the quiescent current and midpoint voltage set on it. I think we did have some issues with it, but got there in the end. Still got charging that because I heard a little pop then as I switched it on. So I'll go around that way, not on this radio because of the massive great speaker. Right, what voltage have we got on here? So this is an 18-volt amplifier. So we want to connect our negative to there. Let's make sure we're in the off position. Positive to that one. Phone's interfering with it. No one you can save, the kind you save. Nothing you can do, but you can learn how to be. Sarah Connolly with The Angel's Farewell from Elgar's
The Dream of Gerontius. We heard Andrew Davis conducting the BBC Symphony Orchestra and chorus. And Glenn Connery, being a girl, you couldn't inherit the family title or Holcomb. And because you had two younger sisters... Does sound amazing, this. Everything...
When I get to the big smoke, I realise it's quite hard to get into that world, so I find...
So there we are, and the radio that is in question, Andy Scott, is the RP37A VHF Herald, as I've got here. So let's disconnect this now. Let's just pop that power off a minute. And let's try Andy's amp in here and see if we can see what's up with it. I mean, it's going to be capacitors, really. But you never know. It might work. So there's a little pop. So there is a bit of life in the capacitors. So let's pop it on, turn it on. And he's dead right, it's absolutely nothing. It is drawing some current, mind you, so I wonder what's wrong. So let's get the old signal tracer out. It's a beauty, Mike, isn't it? This is the ELAC speaker version of the RP37A, 35A. It's a monster now. Chris over in the US wants this radio, but that is a monster speaker, isn't it? If you compare it to one of the normal Hacker speakers, if I can find one to hand. Have I got one here? I'm sure I've got one somewhere. In fact, I know I've got one in the bedroom, actually, which is a bit strange, isn't it? But yeah, I do keep my Hacker speakers nice and close in the bedroom. So this is the Goodman's version of the speaker. So you can see that the magnet is quite a lot smaller. Let's just turn that off a minute. The magnet is quite a lot smaller. But yeah, you'll have one of these versions in it. I mean, this one's a bit poorly. It's got a nice big rip in it to repair, so it's just a spare speaker, that one. Right, let's get a beer underway, actually, because it is Sunday and it is traditional, really, that we get a beer out. Has to be done, unfortunately, but I'm going to have a Brewdog layer cake, so I'm going to start as I mean to go on. This is one of my favourite of all-time drinks. Tastes absolutely amazing, and it's 7%, so it's quite strong, but it's not quite a pint. You want the cheapest way possible, Andy, do you? No worries, mate. The whole thing with the Sackers? Where's the goat gone? The whole thing with the Hackers is they do sound good. And I mean, you can mess about with capacitors to try and alter the sound, but you're not going to gain a lot, to be honest. It's not a hi-fi end of the day, is it? Right. So, cheers, everybody. Have a good Sunday, and have a good week as well. Let's get my water glass out of the way. Afternoon Mac Vision. Okay, right. So let's have a look, see if we can find out if there's if anything's wrong with this. And this is my homemade signal tracer, but It does work very well in the audio stages. Not so great in the RF stages, although it'll work in the IF. But, not lower down. So let's stick that on. Better get something to put this on a minute. Stop it shorting out. Bit of foam or something. What have we got here? Bit of foamy foam. I don't know if that's conductive foam actually, but I don't think it is. Put the power back on again. Turn that on. So let's have a look. So this is our signal, and the input should be. Well, just touch something then, and it came to life. Did you hear that? So input.
You talk about hesitating. It wasn't groans, it was derided.
So we've got a signal coming into the radio.
Yeah. Without hesitating, repeating or deviating, can you tell us all about your fashion or my fashion essentials starting now?
My fashion essentials, just for me personally.
Bear with
speaking,
me.
Trousers, trews, slacks, leggings, all kinds of coverings of the lower part of the body.
So I'm just probing the input from this socket here, from the IF stages, well, from the volume pot.
It's because I wear. What happened?
I'm sorry, I know it's...
Okay. So that is. There. So that goes.
But you know what? That's yours.
Way to that. So T1, we should have that signal on the base of T1, which we have. So that should come out through the collector. Which it isn't. So we've got nothing on the collector of T1, but.
So Jade.
Is that because T1 is bad, I wonder? Let's just pop him out then and have a look. So let's turn the desoldering tool on. So let's get you in a bit closer. So there's T1. So I say I was just probing the collector, nothing on the emitter. If we go to the base, which is smack bang in the middle, let me just
And a number of people are wondering why I include the ability. I'm happy to tell you that my fashion essentials mean that if I am ever accosted or attacked...
So I've got a signal on the base, but nothing on the collector. So it could be that, it could be something further down the line. You can never really tell with these amps. They are a bit of a minefield. So I've just turned my desoldering tool on, so we'll wait for that to heat up for a minute. We'll just wait for that to heat up. Harvey, how you doing, mate? Yeah, no worries, Rob. I'll look at that for you. Supposed to be a street party here, but weather no good. Yeah, take a brolly, Harvey. Don't worry about it. Get a brolly up over your head, mate. Hi, Mac Vision. Yeah, it is a BC 148. I believe you can just stick a BC 108 straight back in place of that one. So that's what we'll do. Thank you, Rob. Cheers, everybody. Right, we're up to temperature, so let's have that one out a minute and see. It looks like it's been messed with, actually, this transistor. Yeah, it's definitely been out before, this one. So let's pop that one out. And so it is a BC 148. So let's see if I can find the component tester, and we'll give it a test. If I can find the component tester, that is. I did do a bit of a clear up in the workshop here, but I only cleared one half of the bench. I've got the other half still to do. Now, what have I done with that? Now, I was using that the other day, so I wonder if it's still downstairs. It might still be downstairs when we were doing our outside workshop with Les. No, don't think it is. Okay. What have I done with that then? It's got to be on this mega pile of junk here. Buried deep, I'm sure. There he is. Yeah, so I have actually finished that radio now. That's Ferguson Caravel, was it? Yeah, that's actually done and dusted. So I'll be making a video on that one this week. Mike! Thank you very much, Mike. What are you saying here? You didn't get the Derby winner, but it had a £5 each way on the second at 150 to 1, £10 each way on the third at 28 to 1, £5 each way on the fourth at 80 to 1. Gambled £40, got back 306. You are the man, Mike. You are the man. As I say, my dad was mad into horse racing. He spent a lot of money on trying to sort of win over the system. He did well for a while, but it didn't take too long, I don't think, before he started losing money. So he initially won quite well, had a nice kitty going, but then the more you put back in, the more chance you get of losing that, I suppose. And Mac Vin, thanks very much, mate. Thank you very much. Right, let's try it. Let's get on the component tester. Let's just do a bit of light alteration. So this is my component tester. This is a great bit of kit for testing components. It will test a lot of components as long as it's not got more than 3 legs on it. So it does diodes, basically semiconductors. It does voltage regulators. All right, let's have a look then. Okay, that transistor is not the problem. Ah, interesting. Let me think. I'm going to stick a BC 108 back in there anyway, because they're less noisy, and I've got quite a few BC 108s, so I'm going to pop one of those in. I've got some with pre-bent legs as well, which I got for a very reasonable price. These ones here, little curly legs on them. Lock fits are notoriously prone to going wrong, although that one is measuring okay. I'm going to swap it out anyway. Seems a bit of a waste, I know, but it will eventually go noisy and potentially will fail, so I'm just going to pop that one back in. I don't think so, Brett. It's usually prior to the outputs. So you can see someone's taken that transistor out before. It could be that the signal's being chucked straight to ground by a dodgy cap, which is, I suspect, what is the case. So let me just pop a little bit of flux on one of these legs. It's going to pick up a bit of solder on the end of the iron. I'm just going to quickly tack that one in. There's some very bad soldering on this board. I'm really not sure. Someone's added the transistors out, I think. So I'm using some flux on it because it doesn't look great. Change T4. Yeah, you could well be right, Mick. Usually that is the one that cops it if the caps go, but that's a bit better soldered. It definitely does look like this one's been out as well. T2. But T4 is this one here. I'll stick it on the overhead camera. So T4 is this one here with the nice blue heat sink on it. They're notoriously bad. I think it's an AC128 or an AC123, something like that. So that's you know, we'll check some of these caps first. So let me have a look at what where this goes next. So the collector comes off there, comes around here, and it goes up to this little capacitor here. So if C5 is shorted, that will stick the signal straight to ground. So I don't know if we can check that on the multimeter to see if it's shorted. We could try it, but the multimeter tends to just charge them up. Let's have a little look then, see if that one's a problem. Let's put it on ohms, Graham. Be good. No, 21K. So that one's not shorted. Let's have a look at this one on diode mode then, T4. So where's the base? The base is there, so should have a connection. So got a diode there. Got a diode there. Well, T4 isn't showing bad, Mike. Let's try T2. Hang on, T2 is not giving me any readings. Let's just swap the probes around. So got a diode there. Diode there. T2 has been out and gone back in again by the looks of it. Just trying to have a look where our input is. That one, that goes there. T1 collector comes up, also goes to that resistor there, R3, so let's just check that resistor. Make sure that one's not shorted. No, 5.6K. It never shows bad, but you always change it. Let's pop it out and have a look then, Mike. So the base is the one with the green on it. Right, so T4 is now out, look. There she blows, T4. Let's pop this. Now, what tends to happen with these is they go very low gain. So let's hook it up. We'll go blue with blue as the base. Here we go. Now that's taking its time, isn't it? Ah, okay, now let's just double check that we've got a good connection on the leads, because very often if the leads are dirty, then you don't get a good connection and it won't read. So let's just redo those leads, just try it again. No component detected, so that would tell us that T4 is kaput. So let's have a look to see what T4 is today. And T4 is an AC128. Quite an expensive transistor these days, but I have got some with the heat shield already built into them. And these are, some of these are matched pairs. Now what's this? AC128K. Okay, so these ones here, these AC128s, they've already got the heat shield built onto them, look. So what it is this is a Telefunken or Siemens version of the AC128, and it's in this different aluminium can. So we don't need the blue one anymore, so it's already got it. It's strange because it was showing diodes on the diode test, wasn't it? But we'll check that again in a minute. It's certainly not showing as a transistor. Now let me have a look here. I'm going to connect this one up to the tester. It's just, unfortunately, these are quite fragile, Rob, and it only takes one of these capacitors to fail, and it could take it out. So although I'm going to change this, I need to make 100% sure that these caps are okay before we fire it up again. So I think what we'll do is we'll leave putting that one in for a minute, and we'll check out some of these capacitors, because it's just too risky. So let me get my ESR meter in, and I'm going to check these in circuit. Now some of them are going to read in circuit leaky, in which case the only way we can test them properly is to take them out of circuit. But I think what we'll do is we'll use the main camera here, and we'll come in a bit closer. A bit easier to see like that. Wenlock's saying been cold and wet. So certainly looks like you were bang on, Mike. T4. It is always a problem. The other one that I do get problems with is T3 on these amps as well. But T4, you're quite right. That seems to be the one that cops it. So what we need to do is just have a look at these capacitors, because what I don't want to do is put a brand new expensive transistor in there just to find that I take it out again because we've got dodgy caps. So let's have a look at the capacitors that are around this one. I mean, this one's been out before. All the traces are absolutely mullered on that. Absolutely mullered, and that's not me. So this board has been got at. I mean, I don't know if you can see, but we've got no traces on two of these. I can sort that, it's not a problem. But it's definitely been got at, this one. You can see T2 has been out as well. That's been badly soldered back in. So I'm going to pop that one out and put another BC108 in there. We've got a lot of these carbon caps with, carbon resistors with the press-on end caps, which are pretty horrible. But I suspect that the problem we've got is capacitor. So let's try the first one. Let's go through them in order, and I'm only testing the electrolytics. This one feels very loose. This is C2, which is supposed to be 100 microfarads. So let's okay. Now I can see a problem there straight away. I did say it's a bit loose, didn't I? So let's go to the overhead camera a minute. Let's take that out of the way. But I don't know if you can see, where are we? This cap here. And we have got a break. See that? We've got a break in the track on that one. That. So that one is actually broken off the track. Great. Let's pop that one out. Where's that go to down there? So let's just see what this one measures. Anyone want to hazard a guess? 100 microfarads at 25 volts? Anyone? $100 microfarads, 25 volts. Anybody? Any takers? So we've definitely got a break in the board there anyway. 177, Brett's saying. 137. It had an ESR of 0.78, so it wasn't, in theory, a bad cap, but we've certainly got a break in the board there. I mean, you can see it much more clearly now I've took the cap out there. I mean, it's not really focused there, but you can see the board's lifted there. That. See that? So I'm going to have to put a bracing wire across there to repair that. Or, yeah, it might be that I can put the cap in. Anyway, let's have a look. Have you all had a guess at this one? What's Mac asking? A question for the chat. You're working on one of these amps because the two bias resistors burnt out. They burnt out? That's unusual, Mac. Possibly a short on one of the outputs has pulled a lot of current through them. $110, Ben, obviously. Right, let's try it. $140, that one's reading. So that's gone up quite a bit. It's probably plus 50% on one of these, so probably just about in spec. ESR is not too bad either, so that certainly wouldn't have killed that transistor. I believe the next one's 100 as well, so let's pop that one out while we're at it, because it's right beside it. Just turn my signal tracer. Just get this one out. The traces are pretty fragile on these, so you do need to be careful not to use too hot an iron on them. Maybe that's what someone's done there in the past, I don't know. So this is another 100, so what do we think this one's going to measure? Another 100 then. This one's a slightly lower voltage, this is 16 volts. It's going to get recapped anyway, this one. So I'll just get some caps sorted while you decide what that one's going to be. Who was closest to the last one then? Was it Timothy? It was 140, wasn't it? Timothy was 137, so gotta be you, Timothy, isn't it, I reckon? I think that was Timothy, the last one, so well done, Timothy. Right, let's find some 100-volt caps. Now, I have bought some lower voltage ones now. So we had a 16 and a 25 volt, didn't we? So we've got, what are these here? They're 10 volt, 16, what's that? So we've got a 35 volt and a 16 volt. There we go. And it looks like one of them is a Panasonic, rated at 105 degrees. Now, incidentally, the blue Vichys, most of those are rated at 85 degrees. So, although in this application they're going to last a long time, but as far as the lifetime of a capacitor goes, generally, the higher the temperature rating, the longer it will last. So, just a rule of thumb. 230, Mike. Let's do it then. 135. 135. So we've got a 145. Got a 121. I think that's. Oh, hang on. Max come in with 130. Was that? There is a delay on this, so probably, Mac, probably you're in. So let's pop these two in. So C2 was the bigger one. C2 was rated at the 25 volt, I believe. Let me just double check because I can't remember. I can check on this one, can't I? Mind you, these are both 25 volts, so that's not going to tell me anything. So it's strange, isn't it, that that there was nothing coming out of the collector of T1, but we had a problem with T4 open circuit. What I should have done, really, the proper way to have done it would have been to would have been to check the voltages, really. It's a bit naughty of me. I should have done the voltages, really. It's not going to tell me, is it? It's not going to tell me. C2 was the bigger one anyway, so we're going to go with the 35 volt one in C2. What I'm going to have to do is bend the leg so as it creates a bridge across that pad. It looks a bit of a bodge, but it looks a lot better than putting a jumper wire in, I can tell you. And the other one, C3. Make sure they're nice and even. Make sure I'm on the right. Yes, I am. Let's get these two soldered in a minute then. That beer is amazing. Oh, that's so good. I could just drink that and no other beer, I think, for the rest of my life. It wouldn't do me any good, mind you, but... you know. So this will repair that broken track at this end for sure. So this is the one with the broken track. Let me just get my magnifying glasses on so I can see what the hell I'm doing here. So I want to make sure I've got this soldered on as nice as can be. Got a little tiny stub of solder left here, really. Waste not, want not. That's what my nan used to say. Waste not, want not. Okay, well there's next to no pad left on that one, so that's sorted that. Incidentally, I bought these CK Ecotronic, the ESD safe wire cutters recently, and they were to replace my old Nipex ones that Andrew Alsfer gave me, but I've had these for a long time and they've started getting blunt and I got a little nick. Obviously I've tried to cut something that's a bit too hard, and sadly these are I don't know if I might be able to sharpen these, I'm not sure. I don't see why I couldn't sharpen them and get them back to working, but I loved these, but price-wise this was a better option. The reason I'm banging on about it is because the other day I was using them and I just cut something, I let them spring back out, and all of a sudden this spring let go and shot across the room. I couldn't find it anywhere, so this spring on this particular plier is a load of rubbish. I mean, look, I've just dropped that out now. They're good cutters, but that spring setup is nowhere near as nice as those Nipex ones. So I do like CK products. I do rate CK products, but that spring, I mean, that could potentially have got me in the eye, couldn't it? So not great, CK. But there you are. Luckily, I managed to find it by accident yesterday. Up until then, I'd lost it for good, and I was thinking of having to buy another set of cutters. But you do need a decent pair of side cutters for working on this stuff. They need to be sharp. There we are. That's the first two caps done, and we've also done one transistor. Let me just tidy that transistor up actually, because it's not sitting particularly straight, but I'm a fussy git, so. Right, let's check some more then. So really not an issue with those two. One was a bit high, one wasn't quite so bad. The next one to check is this big 470 up here. Now this one, let's just get the circuit up, look. Let's get the circuit up. Don't forget to check the output pair. Yeah, no worries, Mike, I'll do that. One thing I would say, and it's a really good idea, and it's something that I haven't done, but I need to do it. You can put a current limiting lamp in series with these. So I know we only think about like series lamp limiters for valve stuff, but they do work all right for transistor stuff as well. I mean, I can set a current limit on my power supply so as it's not going to draw enough current to kill the transistor. I can set it really low, which I probably will do. But as I say, I think the issue's been the broken track one, and that's taken out T4 potentially, or one of these capacitors has taken out T4. So let's get the circuit up a minute, because that's what I was going to do next. I always get sidetracked, don't I? I'm easily led. That's the problem. No, it's not there, Graham. It's on Explorer. Okay. So let's just get the circuit up for the output stage. So you should be on my screen now, I hope. Let me just double check. Yes, you are. So this is T4. As I say, we had the signal coming in to the base of T1. I mean, this is showing it as a BC108. Look, so this is a slightly later version. But we had nothing coming out, so it could be that C3 was a problem, or C2, but that's the two that I've just changed. So the brake was on the positive of C2. So basically C2 then would have been out of circuit. If the brake was here, what would that have done? Because C2 was... oh, hang on, C2, no, not C3. So the brake was here. So it looks like these two are in parallel with R2 across them. So that would have certainly altered the capacitance. Would that have chucked that signal down to ground, though? I don't know. You can see that that is the emitter of T4 on that line as well. So that being open circuit there. Just looking at, let me just look at the board a minute. So that actually is the whole line. That is the power supply, that line. So yeah, that is the HT. So this is the HT, I think, coming off of pin 3. So if that was missing from there, there would be no HT coming down to this at all. Hence why I said I should have probably checked the voltages first, because that would have confirmed that there was no HT on T1 look. Okay, I've answered my own question really, but yeah. So yeah, pin 3 by the looks of it is the HT line. And yes, it definitely is. So yeah, HT comes in there, and I've got a brake here. So there's no way that we'd have had any voltage on T1 or T2. And maybe that pushed too much current through T4. That may have damaged T3 as well, but we'll see. Hopefully it hasn't, because again, an OC71 is like rocking horse poo, unfortunately. Right, I'm babbling on again, aren't I? Farindu from Sri Lanka. Welcome, mate. Glad to have you on board. I've got my funny goggles on. Fat Tony, how you doing, Tony? Yeah, you do need flux, Chris, because all the solder's oxidized quite badly. How about that bias pot? Working on a 60s Pioneer yesterday, both bias pots were open. Yeah, these skeleton pots are usually okay. They're usually okay. I have had the odd one that's very twitchy, and I've replaced them with with modern types, but normally these ones are okay, Thomas. Usually a quick squirt of switch cleaner and a quick action back and forward will clean them up. The wipers get quite tarnished, and you can see this one is really black. I mean, that's a silver contact there. That should be silver, but he's actually black. So we've definitely got a bit of tarnish on that. And the other one has got no tarnish at all. So I can show you that under the overhead camera, I think. So yeah, can you see that that bias pot there? You see that's black. Well, that should actually be silver, not black. We've got a fiberglass pencil here, brass. Always the last one you find, isn't it? Steel, yeah, typical, and fiber. So if I just touch this one with a fiberglass pencil. Oh, there you go. That's the colour it should be. So that is quite badly tarnished. So it'd just be a case of giving that a bit of a squirt with the switch cleaner or the fader lube. Probably the fader lube would be best, and that'll clean it up. If you notice the other one down here, that one looks like brand new. So I can see a trace all the way around, so someone has twiddled that one as well. This is the problem. I think this has failed and someone's given it a blimmin' good old twiddle. Not Andy, I'm sure, but whoever had it previously has given it a good old beast in. Just having a quick visual around the other parts. I mean, there's a strange bit of solder on that one. See if we've got any other broken tracks. We've got really bad soldering on both of these transistors, so that one's going to have to come out as well. So it looks like we're going to stick another BC108 in there. Just looking at the resistors, make sure there's nothing burnt. No, the rest of it looks okay. As I say, this transistor in here, these can go as well. It's very rare for the outputs to go. This is T3, which is the driver transistor for the output pair. No, it's not. T4 is. That's a pre-driver then, T3. T4 is the driver, and T5 and T6 are the output pair. I have changed them before, but it's not very common. Just looking down at this blob of solder on here. Oh, well, that's just a bit of excess solder. Right, let's crack on with the other capacitors. Let's check this 471 then. Let's pop him out. I mean, I'm going to change him anyway, so... Let's make sure that is written which is which on the board, which it is. So this is a 470 at 10 microfarads, so get your thinking heads on then. 470 at 10, what's it going to be? And Mike has done a lot of these, haven't you, Mike? I think these are one of your favourite sets, aren't they? Well, the Sovereign 2s, I think, are your favourite set, Mike, aren't they? I think you've done an RP18 though as well. So 470. Now this particular capacitor, I know, say transistor then. This particular one, I believe, sits across the speaker. Now this is it C10? Yeah, C10. So C10 is here. So we've got the headphone socket, and don't forget the headphone socket can be an issue on these. you can have a dead radio, and it's because this headphone socket's gone open circuit. So if all else fails, I mean, I should have tested this first. Again, really, I should have checked that headphone socket. But this is the capacitor in question, and this one will kill the set dead. Let's have a look. Where does it go? It's not across the rail, but it's certainly the sort of DC blocking transistor for this speaker, isn't it? So we certainly need this one to be good, otherwise it could put DC onto the speaker. Okay, so what do we think then? What's the verdict? 470 at 10 WV working volts. Done both sets, Mike? No, I know it wasn't you, Andy. Robert, how you doing, mate? Bit damp. It's actually, the weather is, touch wood, the weather is sort of holding off here at the moment. It's a bit misty out there, so I think it could be a bit of drizzle about, but certainly I don't think we're going to have any major showers. What's Ed's the Shed Fudwinkle? Just had to buy a new K1503. K1505V became ill on full power. You blew up the 30 amp PSU when you keyed up. Hell. You blew up the PSU. Shorted something in the amp. I'm not familiar, Ed's the Shed. I really don't know what the K, is it KL or K1503? K1505V became ill on full power. Is that an amateur radio RF amplifier, Ed? Oh, it's RM, yes, okay. KL503, now I'm with you. Yeah, that is an HF amplifier, isn't it? I suspect you've done the output transistors, I suspect. Was it, do you think it was reverse biased? As a relay jammed on? I'm not sure. I have got one of those to look at soon, Edda Shed. I must get around to going and picking it up. So it's 300 watt linear amplifier with a preamp. Thanks, Chris. It does tend to be, I know it's a bit cliche, but it does tend to be output transistors in a lot of that kit. A lot of those linear amps and that tends to be the thing that gets killed first for some reason. I don't know why. But either you put too much power into the thing. Certainly the one I've got to have a look at, as I think it's had 100 watts up it, and I think the maximum was 10 or 20 watts, and it's had 100 watts up it, so it's probably fried the outputs, I suspect. Yeah, Les is saying it's a MOSFET, so it'll be shot. Right, let's do this one then. 470. Oh, 530. Again, not massively out. Who was closest to 530 then? We got 501, 480, 490, 680, 510. So probably Timothy again at 510. You've done the double, Timothy. So yeah, a bit high, not a game changer. Let's get a 478. What's the voltage on that? 10 volts. I haven't got anything that small, I don't think. Where's my other 470s? What's that one there? don't know that one. I'm not confident with that one. What's this one? 470 at 25 volts. There we go. That's a nice... Oh, actually, no. We got 16 volter. Let's stick a 16 volter in there, because that one was only a 10 volts. Let's pop a 16 volt. I have got another 10 volt, but I do prefer to go slightly higher. These things are built to a cost, and I'm sure if a 10 volt capacitor would have done, and it was cheaper than a 16, they'd have chucked a 10 in. So I'm going to pop a 16 in there. Pop that one in. So we haven't really found anything disastrous yet. I believe it was the broken track that's caused the issues on that one. Let's pop a little bit of flux on. Say this is an old board. And, the flux, sorry, the solder on it is long since decayed, oxidized. It does pay you on these boards as well to just go over the 5-pin connector and also the speaker terminals, just to make sure that they are a good connection. Just good practice, really. That's that one done. Oh, that's not particularly straight, Graham. Okay, well, that's fine. So there's only 3 caps to go. Let's try C5. C5 would have took our signal to ground, but it was measuring okay in circuit, but not to say it is any good. So this is a smaller value. Where's my forceps? So C5 is 6.4 microfarads. 6.4 then. So closest I got to that is 6.8, but let's have a guess at what this one's measuring then. 6.4 microfarads, so I don't know what the voltage is, 25 volts. So it should be less than 1 ohm ESR, but you never know. Okay, Ed is saying it was too much power. Yes, you didn't drop it down when you went on to AM. You've probably almost definitely fried the MOSFETs then, Ed. Could be expensive. Some of those MOSFETs are expensive. Danish, you are reaching it. You're reaching the UK, mate. QRM, you've been interfered with. Fat Tony 7. Well, you're close. I mean, you've got confidence in this little cap. I'll give you that. 6.8. It's a bit of a funny size, but I do keep them, I think. Yes, I do. And what's the voltage on it? Did I say 25 volts? 6.8. I haven't got a lot of 6.8s actually, but this 63 volts, that's a bit of a jump up, isn't it? What's this one here? Oh, that's 0.47, I don't know what that's doing in there. And the rest of those miniature ones, I'm not going to stick a miniature one in there really. So 6.4. What's the verdict? Good or bad? So hopefully we can get this board done today and get it straight off back to Andy ASAP. He can get and have a play with his nicely refurbed RP37A then. Right, let's do it. Oh, it's got, whoa, look at the ESR on that. That is knackered. 5.8 ohms ESR, look. 8 microfarads, or 8.08. Wow, Thomas is 8.7. 8.2 for Timothy. Timothy's done it again. You're on a roll, Timothy. But that is a knackered capacitor. 5.8 ohms, that's pretty much a resistor now rather than a capacitor. So that could have been our problem. Let's just pop the legs off of that one. Right, what else have we got here? 2 left to go. Now we've got a bigger one, 125 microfarads next. That's a bit of a strange size. 125. Have I got 125? So I might have. Get out. Right, 125 next then. Like the old high-speed train. Perhaps it's Timothy's oats that's the secret. Timothy's oats. What are we going on about now? Are we deviating again? Right, 125 then. Let's have a guess on what that is going to be. Right, I've got 120s. What's the voltage on that one? 16 volts. So I'm going to stick a 120 in there. I could stick a 133, couldn't I, really? Is there a one? No. I thought I did actually have a 125. I got 120s anyway. That's a 220. Cracking up, some of these are in the wrong hole. $50 volts, what's that? 25 volts. Oh, hang on, that's 470. $220, so it looks like it's going to be one of these. Is it 105? Yeah, there we go. Let's do it then. $150. Not bad, not bad. Can't complain about that, really. That one's okay. Right, let's just pop this one back in there, and we've got one more to do. One more to do. I should really have the extractor going for this, but it's a little bit far away from the work area, so. It's not very good. Let's just alter that one. Got to make it look fairly nice, haven't we? Can't have it looking ugly. C9. So who was closest to that one then? You mixed up Timothy and Danish. You're back. Welcome back, Rob. Where have you been? What have you been doing? Right, C9 then. This is 40 microfarads. 40 now. 40 microfarads, Rob. I think did we check the 125? We did, didn't we? Yeah, it was 150. It was 150, wasn't it? So who was closest to that then? 144, was it Brett? I think it was Brett, wasn't it? I think it was you, Brett, was closest. Right, last one then, 40 microfarads. Didn't have the sound on. I like the sound because it says if you got a bad one. So 40 microfarads. Are we all there? So we've got 60, 44, 57, 68, 46, 52. Any advances? As I say, this is a 40 microfarads, which is an unusual size. We're going to have to stick a 47 in there. What was the voltage on that one? 16 volts. 10 volts. 50 volts. It's going to be the same again. I thought I did buy some smaller ones of these. 50 volts. No, 50 volts is the smallest 47 I've got. I've got 10 volts, but that's too small. Thanks, Andy. Get in there, mate. We're getting there. I need another BC 108 because these tend to be lower noise than the lock fit versions. Right, let's do it. Let's push a button. Okay, 47, not a million miles out, fairly high ESR. So the only real one that was a major problem was that 6.4 microfarads. There we are. That's the end of today's capacitor bingo session. I think Timothy Can was the winner today. I don't know how many he got right, but certainly seemed to get more than most. Okay. So BC 108s are relatively inexpensive transistors. The only real reason I'm going to change it is because it's really badly soldered in, so I've got to take it out, clean it and put it back in again, so I might as well stick a slightly better transistor in. That's that one. Right, let's stick the BC 108 in. So I'm going to take this other lock fit here out. This little nasty thing here that's badly soldered in. damaged pads as well by the looks of it, so let's get that one out. Let's pop a BC 108 in there. Grab a bit of solder on the iron, just to tack it in place. Yeah. There's not a lot of pad left on those either, I don't think. Let's have a look. Okay, that's got it. Now we need to stick our new transistor in, our replacement for the poorly other AC128. So that's got to be the base there. That's the base. It's usually the emitter's mark, so it's in that way round. So again, we've got some dodgy pads here, so I'm going to need to bend the legs right over on the board in order to combat the bad pads. I'm going to bridge them right across to the next pin as well, just to make 100% sure. I know it doesn't look particularly pretty, but it'll do the job. There we are. Just so that's what I've done. I've bent the legs, as you can see, right the way across to the next terminal. And that's secured them to the board. Not the prettiest thing, but it's slightly better than putting jumper wire in. There's my new transistor. Looking nice and shiny. So most of the AF driver transistors are changed then. So I've done T1, T2 and T4. Plus all the capacitors. So that should be good to go. So I'm confident now that thank you, Mike. I'm confident that that's going to be okay. So what I'm going to do, I'm just going to set up a proper current limit on my power supply. So I'm just going to connect the two together, turn the power supply on, and I'm going to set that down to hopefully about 30 milliamps. Just in case. There we go, 30 milliamps. So I'm going to connect back up and we'll see if we've sorted this amplifier. Let's get my overhead camera out of the way. Now I've set the current limit just in case there is still a problem with it, so let's pop the power on. Okay, it's gone up some. Okay, we've got 18 volts of 30 milliamps. So.
Don't go out.
Oh yes.
Russians catch men and force them to go to the war against Ukraine. It's awful. It's awful.
Just looking at the power supply.
How relaxed and calm you have been.
But here a lot of charity organizations helps different churches try to help. So it's a huge support. We are very thankful.
Yes. Woohoo, she's working. Thank you, Rob. You had to empty the ashes down the field. What's Mike saying? You fitted a new element in your old 25-volt Antex and got a new tip can. A new tip can. Oh, a new tip can never have enough irons. Yeah, I do like the old Antex irons, Mike. I've got a couple up there, actually. That's what I started out with, the Antex irons. What have I got? I've got that one there, which is CS. That's the old CS 18, Mike. 18-watt one. I've got a smaller one than that as well, I used to use for detail, finer work. And that's this one here. Oh, I've got them both still, that. What do you know? That's the other one, was the C15. Now that was my go-to iron for when I used to modify PlayStations. Back in the day. Back in the 90s, that was, I think. Very naughty modifying PlayStations. Right, okay, so next we're going to need to go and set up our quiescent current and midpoint voltage. So I'm going to snip the test link here now. So let's get you in, show you what I'm up to. Thanks, Danish. Cheers, Andy. Yeah, they're great little irons, Mike, aren't they? They're pretty bomb-proof. You can still get the tips from. I've got loads of different tips. And I've actually got one tip that's pure copper, not coated, which is a bit unusual. But they did do some very fine tips for those. Right, okay, let's get the midpoint and quiescent done. So I'm going to need to snip this, this link here that says test in the corner. Snippity snip. Let's just turn the power off a minute. Although I've got the volume switched off, can still push some power through. So bend those up. It does help to stick a wire. You need a wire on the junction of these two bias transistors, R14 and R15. The junction of those is there, so we need a wire on there. So let's get a bit of jumper wire if I can. That'll do. So I'm just going to stick a wire on the junction of these two resistors. This is where the midpoint voltage is measured from. So let's pop a little bit of flux on there. Let's tack that one on. It's just easier than trying to do it holding onto it. That's that one. I'll tin that end as well. So that's my midpoint voltage measurement point. I can use the heatsink as the ground. I need to short out the input to ground. So I need to do, I mean, I've done this, I'm doing this off of the top of my head, but I need to short the input here to ground. So I need to just put a shorten link across there. Just tin those a minute. Does pay you to just redo the connections on these anyway. Because it is a weak point. So let's get a solder leg and stick across there, or a bit of wire. What have we got here? Nice chunky solder leg there, that'll do. Nice chunky solder leg. So I'm just joining the center pin to the input. In fact, that can be used as our ground connection. Okay, right, let's get some meters set up then. Let's get some multimeters set up. Danish native, thank you very much, mate. Good old Stream Elements. Multi, afternoon, mate. For chicken dinner. Excellent. I do like, I think we have got chicken dinner today. But I've got one other drink here, and I'm going back to my favourite alcohol-free drink at the moment. Guinness 0%. So I thought I'd offset the 7% with a 0%, and then really I've drunk 3.5%, haven't I? Excellent. But yeah, alcohol-free Guinness is very nice. And I'm sure I'm going to be doing a bit of drinking later, so I want to pace myself really. I don't want to end up poorly tomorrow. So, cheers everybody. Incidentally, the street party is in celebration of the Queen's Platinum Jubilee, so I'm sure everybody's heard about that. Midpoint and bias is no problem to me. It's not. It's just getting which pot's which, Mike, isn't it? Because I think they're reversed in the instructions, aren't they? There's some strange quirkiness about them. Now this is typical because I had all my there we go. Right, so we need to get set up with the multimeters now. I need one set for voltage and one set for current. And you've seen me do this dozens of times now, so I'm not going to be too instructive about it, so to speak. So we're going to use this this meter for the quiescent current, and I've gone and left my other meter downstairs for the voltage. So I'm going to need to go and get that one. So these two need to be across that link that I cut. So you bet your life they'll be the wrong way around, because they always are. And I need to make sure I've put my meter in the milliamp socket. Right, let me get my other meter a minute, which I think is still downstairs in my rucksack, because we set up an amateur radio station at the Platinum Jubilee Fair on Thursday, so I took a load of my kit with me then to help them out. But they didn't need it all in the end, but you never can tell, can you? So I'm down with that Mrs. Cruncher's lunch by the smell of it. Oh, it looks like she's done some stuff for the barbecue. That's nice. You taking the potatoes and that for the barbie, are you, Carol? For the... Oh yeah, you're in the loo. I think she's in loo. No? Right. This is my voltmeter. So let's hook this one up. So the voltmeter is going from that center tap point. I will get these in shot a bit better for you in a minute. But the voltmeter is going from the center tap point to ground. So that's going on the center tap. Well, the center of those two resistors, and the other one is just going to the ground, which I'll use at the top there. Right, let's alter the camera about a bit. Stick the red one on, which has popped off again, and now the black one's popped off. I really ought to have some decent clip leads for these. Right, so this one needs to be on our milliamps range, this one needs to be on DC volts. Okay. Jed, how you doing, mate? Happy Jubilee to you as well. Bit of the black stuff, yeah. 8.5 volts and 4 milliamps. I think it's 8.5 and 3, but let's have a look. You may well be dead right, Mike. Let's have a look at the instructions. Yeah, 3 milliamps and 8.9, Mike. It says RV3. RV3 apparently is for the 8.9 and RV4 is for the current reading. So let's switch on and see what we got. So we're looking for 3 milliamps on this one, and we're looking for 8.9 volts on this one. Fire in the hole. Okay, this one is quite a way out, look. That one's pretty much bang on, so we need to do RV4, wasn't it, for 3 milliamps. So let's just adjust RV4. Let's get screwdriver. Ideally it would be a non-metallic one, but I've only got metallic. How about that? So we need to let it settle for a bit, but we ain't far off there. Obviously the leads are the wrong way round on this, which is typical. Let's put them in the right way. So you can see it's rising as it heats up. So we need to just let it stabilize for a minute, see where it ends up. That's gone slightly high, so maybe we need to tweak that back a bit. And they are interactive as well, so let's just carry on, a bit of a tweaker. Let's just so that one's gone up now. Let's just tweak that one back a fraction. Where is it? There we are. That's pretty good, isn't it? 8.91 and pretty much 3. You can't get a lot better than that. You have to pay €73 for your signal tracer. That's crazy. That's pretty good, isn't it? I mean, it's rising very slightly. The midpoint voltage is raised to 8.92, and that's dropping slightly. Oh, and I've just knocked the probe off. So let's just bump that up a fraction. Not that much. That one's gone up slightly, so let's alter that one back. If I can get the screwdriver in the slot. Give that a little bit of an exercise because I think it is a bit dirty. Get out. That one's gone higher now. Oh dear. I shouldn't have messed with it. It was pretty good as it was, wasn't it? There. I think we're going to leave it at that. Look, 3.0 and 8.9. What do you think? We're going to get a lot better than that, aren't we? Thanks, Andy. Right, let's disconnect everything, hook it all back up together and just make sure that it's still A-OK. Let's get all the meters out of the way. Make sure I put that back in the right holes because that's my favourite thing, is leaving it in the milliamps mode. I'm wondering why I can't measure anything. So it was a bit high to start with. That could be because I changed the driver transistor, I don't know. Turn the desoldering tool off, I don't really need that now. Get everything cleared up here. I think we're doing all right for time as well, so that's worked out really well. So let's pop my little bridging wires and that off. bridging wire off. Now, I think what we'll do actually is we'll put another wire in there on the on this little bridge. Thank you, Mike and Rob. Andy is pleased. Let me find a nice chunky capacitor leg to stick in there. Oh, that's a nice one. Made for the job. Bit big, but should do nicely. Let's just pop that power off. You can just bend them back together and join the tips really with a bit of solder and flux, but it's a bit nicer to change it, put a fresh one in. Makes it give the untouched look then. Sounds like it's blocked as usual. Let's just unblock that. He says, easier said than done. No, game over. Desoldering tool is blocked. Blocked to bejesus. Oh well. I'll have to use the old solder sucker for that. Let's get this one done as well. My silicone piece is perishing on this as well. It did come with a spare piece of silicone, but I cannot find it anywhere. Typical, isn't it? Let's just get rid of the excess solder from here then. Come on. You know you want to, thank you. And here. Is that clear? Oh, I see, that's the wire from that transistor, okay. Right, stick our new bridging piece in. Why won't you go in there then? Too big? Oh, I've still got solder in there. Okay, I just give it a helping hand. Let's get my eyes back on because I can't see what I'm doing here. Here we are. Right, sew that one on. Just going to move that wire there out of the way slightly. That's my bridging wire for the transistor. Snip that off. There we are. One nice new test link. Right, well the only other thing left to do is to clean up this board. Which is all pretty manky at the moment. Is that engineer sucker any good? It is very good, Mike. The only thing I found, it's a really strong spring in it, so you've really got to grip it hard and push your button, because otherwise it just jumps out your hand. If I hold it loosely, it really does jump out your hand. But I do need to put another piece of silicone on the end. But yeah, very, very good, Mike. Probably one of the best solder suckers I've ever had, so good recommendation, really. Right, so let's get the flux off of it. I'm going to do it quickly rather than use isopropyl. I'm going to use this stuff here, which is proper flux cleaner. It gets it off a hell of a lot quicker than isopropyl. And it's made by Electrolube. I think I got this from CPC, but I'm not 100% sure. The only thing is, you do need to protect your bench because it's quite corrosive. But a little squirt of this. It's got its own brush built in. Put these the visor down so I don't get any splash in my eye. I've got a lot of really burnt on flux on here. Left by hackers in the factory originally, I'm sure. Say, don't use this on coloured PCB. Oh, this is nearly all gone now. Don't use this on coloured PCBs because it will literally take the colour off the board. Some of those painted PCBs. Yeah, I think this is knackered. Looks like I need some more of this stuff, but it is good stuff. I'd say it's a lot more aggressive than isopropyl. Still gone right the way through onto my bench, and it wipes all the yellow stuff off the bench. So we'll give it a final squirt of isopropyl just to get the excess flux off this side. Let's give it a squirt of air to dry it off. Adrian, we mended it ages ago. There we go. Nice clean PCB. Final test time. Let's give it some stick. Get rid of that out of the way. I need to clean my hands. Aki, how are you? Volatile petrochemicals. Yeah, I'm going to need to get some more. It says used by 4th 2019, that does. So, yeah, I think that's probably had it. I've just got it back all over my hands. Incidentally, these wipes here are absolutely brilliant. Not sponsored, but these are great for getting flux and that off your hands. Also gets paint off your hands and glue and all sorts, so well worth it. They're quite porous as well. Derek, how are you, mate? Keith, how you doing? Let's see you pop in. Aki Lino, hi Aki. No gin. Right, yeah, so it looks like I've got to get some more of that flux remover. It is good, but it is out of date, so it's probably why why it's lost its pressure. It's just dripping out of it now. Right, here we go then.
When you put them back on the beds, or you plant plants with them, whatever you with your leaf mold, but that's a normal mycorrhizal activity. And often if you read about making new compost bins, the best thing is to have them accessing open ground, because any mycorrhizal activity that's in Mother Nature
Be careful, I'll get copyright hits when
vegetable.
Nowadays I stay oblivious in the hood with geniuses and illiterates.
1812. Hi Anne-Marie, it's Ray Jappy from Aberdeen, where the sun is shining most beautifully.
Good.
I'd be grateful if you might play Gabriel's oboe. This weekend is 10 years since my wife and I got engaged.
So there you are, Andy, all sorted and on its way back to you next week. Dave, you tuned in for the 2 p.m. start and could have been watching for 2 hours. Oh, David, I'm just about to say goodbye as well. You could have had an early night, Dave. No worries. So there you are. That's Andy's amp done and dusted. So I shall pack that up, Andy, and we'll get that back off to you next week. And you can stick it in. Let's have a quick look, because you did send me a link to your... You did send me a link, didn't you, to your... if I can find the Messenger app. You did send me a link to some pictures. You'll have to catch up later, David, unfortunately. Andy sent me some pictures. I can't play the video, Andy, because it'll possibly crash up the stream. But let's just go to Andy's radio. So this is the radio that this amplifier's come out of. Hopefully you can see that. I've gone full screen. Let me just double check that you can see this. No, you can't. So screen cap, cube. So now you should be able to see it. So this is Andy's VHF Herald, which this amplifier's come out of. No, that's wrong. That's my details. It looks nice, Andy. You've cleaned that up lovely, mate. Yeah, very nice. Brilliant. I don't know. We can try playing the video, see what happens.
Neighbour Sheila have organised afternoon tea for our close. We're all so busy day to day that we rarely speak to our neighbours, so it's the perfect opportunity to have a cup.
Excellent. Well, that's actually working. That's working with the amplifier from Andy's other radio, so he's just shoehorned that in for the time being. So, Mike, thank you very much, Mike. You watch it in replay tomorrow. Yeah, no worries, David. Anthony, you turned in for the 2 p.m. I did put notifications out there that it was 2 hours early today because I'm off out to a street party now. So there's a street party down the road, starts at 2 o'clock today. So I'm sort of a little bit late for it, but not too bad. Poor old Anthony. Sorry about that, Anthony. Story of your life. Thank you, Andy. That's pretty much all I've got for today. What I was going to show you was the box for the. Can you remember the Hacker? Let me just get this in camera. Can you remember the Hacker power supply I was working on? Can you remember the Hacker power supply, the P909? Well, I've patched the side up now. It doesn't look particularly pretty, does it? But I've patched the side up now, and I used JB Weld. And what I did was I stuck some Kapton tape and some cardboard on, and I used it as a backer to fill it up. I sort of heat welded it. This one here was broken completely off, if you remember. But it doesn't look particularly pretty, but it's. I didn't really want to respray it because I don't know whether this green colour is. I mean, my thoughts are this green colour is. This green colour is possibly tobacco that's oxidised with like a metallic paint. Because if you look at the paint where I've just broken through it with a sandpaper, there's a very shiny metallic silver underneath this greeny colour. So I think that metallic silver may have had some sort of metal in it, and that this is a reaction with nicotine and the original silver colour that it was sprayed with. I don't know 100% for sure that that's the case, because it does all look pretty green. Now, I have tried soapy water on this, and I've tried isopropyl on it. The only thing I haven't tried on it is Goo Gone, because I cannot find my Goo Gone anywhere. The Goo Gone is gone. But, yeah. So if I get the actual innards of it, it's been a lot of work to get it to that stage. So this is the innards of it. You remember we replaced the capacitor that was causing the problem, and that just slots in there. It's a 50-50 chance I get it in the right way round, and I got it wrong. That sits in there, and we have a repaired power supply. I say you can see a little bit of glue in there as well because that side was cracked, but I thought rather than respray it, I'd try and keep it original and show its repair. That is absolutely rock solid now. That's stronger than the original plastic. That JB Weld is brilliant stuff. So it's all sitting nice and straight as it should be. It's just a case of sticking these screws back in. And they all tighten down properly now. I've reinforced it inside. I've heat welded it with the soldering iron. And then I've gone over the heat welding with the JB Weld. Because before there was one of the screws wasn't catching at all because all the insides had broken on it. It's obviously been dropped from a high height. But, there we are. All back together. A very rare Hacker P909. So yeah, I'm really pleased at how that's come out. I'm not going to mess about with it anymore. It's a functional piece of kit, and it will look very nice sat in a one of the 9-volt Hackers. So there you are. I thought I'd just show you that as a finale. Look. Let's just catch up. Thanks, Mike. Anthony's still got to catch up from when you were in hospital for 19 days. Yeah, it's only a 2-hour stream today by the looks of it, Anthony, so it should be up a little bit later on, and hope you're doing okay, mate. Has anyone lost me? I'm still here. All smoky. Yours look the same. You've got some of them. Have you, Brett? I didn't know you had a 909. It's like a green colour, Brett. It's like a greeny, almost like a metallic green, but certainly sanding through. It is silver underneath that green. Obviously, you've got grey plastic. I don't know. Catch you later, Mike. Thanks, Keith. Yeah, no worries, David. And hopefully this week coming, I'm going to get the video done for your big Hacker valve set, and that's going out to you in Australia. I think probably week after next, David. So good stuff. It'd be great to see that on your channel. See how you get on with it. So what's Brett sending me? Brett's sending a picture of the of his things. No worries, Brett. I'll have a look at that later. So I'm going to call it a day at that, people. Thanks very much, everybody that's put the super chats in and the tips through PayPal, through Stream Elements. Much appreciated. And I'm going to get out to the street party. It sounds like Mrs. Cruncher's cooked up a load of food, so I think we're taking down. Looks like she's got dauphinoise potatoes and cauliflower cheese and all sorts going on. So brilliant stuff. Yeah, I will get it out to you, David. I promise you, it's going to go out within the next 2 weeks. It'll be off to Australia. So I will do up a little video, but I won't release it quite yet. Cheers, Harp. I'll try not to drink too much. No worries, Anthony. A lot better, but glad you want to have a computer instead of the phone. Yeah. So yeah, it's a fairly simple stream today. It was just really repairing that that amplifier, but it did turn out we had a broken track. Really, we had one dodgy capacitor and an open circuit driver transistor. So those 3 things really killed it dead. But those amps never usually got too much wrong with them. It's normally capacitors and the odd transistor, and away we go. Catch you all later, everyone, anyway, and be good. Take care and all the rest of it, and I shall see you next week. Bye for now.